Okay, so this is the second attempt to explain the law of cosines. So we're given two sides with side length A and B, and then there's an angle theta between them. And the question is, given this information, what is the length of third side C? And so how do we actually start by doing that? Well, we don't actually know how to just compute a third side length from two known side lengths and an arbitrary angle, but we do know how to compute the hypotenuse when we're given the two adjacent sides for a right triangle. So the first step is to try to decompose this triangle into right triangles and to proceed as far as we can and see what we get. So to decompose it into two right triangles, we just drop this perpendicular line here to actually divide, the base into two parts, and now we get two right triangles on either side. And then let's give some name to these length, this base of this right triangle. So B is, of course, the entire length of the bottom side. So let's call this small distance here D, from here to here. Let's call the distance from here to here E. So we drop down the perpendicular line from this vertex, and it cuts the base into two sections with length D and E, and D plus E is going to be equal to B. Okay. So let's label this thing here H for the height. So what do we actually know from this diagram? Well, we know that H squared plus D squared is going to be equal to C squared, because it's a right triangle here, and these are the two adjacent sides to the right angle, and C is the hypotenuse. So we get that H squared plus D squared is going to be equal to C squared. Okay. Now, how can we actually simplify this? Well, we want to put this in terms of B. So the first thing we notice is that D can actually be expressed in terms of B and E, because D plus E is going to give us B. So D plus E is equal to B. And if we just manipulate this algebraically, this gives us that D is going to be equal to B minus E. Right? Okay. Well, here we have the expression D squared. So what is D squared equal to? Well, we know that D is equal to B minus E. So what is D squared? That's going to be B minus E quantity squared. And in algebra, how do we actually expand the square of a difference? Well, that's going to be B squared minus 2BE plus E squared. So expanding out the square using algebra, and we get this expression for D squared. So now that we have this for D squared, we can sort of substitute this into the top expression. So instead of H squared plus D squared, we get that H squared plus D squared is equal to H squared plus this thing substituted in for D squared. So that's going to give us H squared plus B squared plus 2BE plus E squared. Now, it's addition, so addition is commutative and associative, so we can sort of move things around and add it in any order we want. So instead of adding it in this order, let's first add H squared and E squared. So add this one to H first, and then add in the rest. And now let's just look at this part, H squared plus E squared. H is this length, E is this length, but then, these are the two adjacent sides of a right triangle, and we know that the sum of the squares of the two adjacent side lengths is going to be equal to the square of the hypotenuse, which is A. So that means that H squared plus E squared is going to be equal to A squared. So what does this say? Well, that says that this whole thing here is A squared, so this whole expression becomes A squared plus B squared plus 2B times E. And now the whole thing is we know what A is, we know what B is. The only thing we don't know is what E is. But just given trig, we can actually find E by A and this angle, right? Because as you know, we have a right triangle and we know this angle, the ratio is fully determined and there's a name for that. So what's the name for the ratio that describes some ratio between E and A? Well, this is the adjacent side and this is the hypotenuse. So the ratio that we're looking for is cosine, right? So E divided by A, so E is related to A by the cosine of theta. Okay, so actually, since we're running out of space, let me just erase this. So that means, we get that h squared plus d squared equals c squared, and we got an expression for d squared, and we substituted that in. Furthermore, we combined this h squared with an e squared, and we simplified that to a squared. And so this whole thing here, a squared plus b squared plus 2be, is the same thing as just h squared plus d squared. So that means that it is also going to be equal to c squared, because this thing is equal to h squared plus d squared, and h squared plus d squared equals c squared. So this whole expression is going to be equal to c squared. Okay, so that means that I'll just erase all the previous things before here. I came up with this step. So we know that in the end, our formula is going to be a squared plus b squared plus 2be equals c squared. But we just don't know what E is, so we have to write that down. So again, as I mentioned, E is related to A by the ratio of the adjacent to the hypotenuse, which is cosine. So that means E divided by A is going to be the cosine of theta by definition. So the right triangle adjacent divided by hypotenuse. And then multiplying by A, we get that E is equal to A cosine of theta. So this gives us E in terms of A and theta. So what we have to do now is just plug E into this formula, and we should be able to, get completely obtain c squared from just A, B, and theta. So, well, let's do that. So, okay, so everything is still the same. So A squared plus B squared plus 2 times B. But now we can substitute in this whole expression for E, right, which is going to be A cosine theta, and then that's going to be equal to c squared. Okay, we'll just erase this. And yeah, so that's pretty much it. And then, so this is the formula for the law of cosines, and normally because they always normally want A and B to be in the order A and B, then we can, of course, because multiplication is also commutative, we can switch these A and B around, and we get A squared plus B squared plus 2ab cosine of theta, the angle between A and B, is going to be equal to c squared. And so, after all of this work, we end up with this formula, which is the law of cosines. And so again, the law of cosines is given two sides, two side length that's known, that's adjacent to this angle, we can use this formula to just find the length of the third side. Similarly, for algebra, we can also solve for theta in terms of C and A, and it also says that if we're knowing three sides, then we can find the angle opposite the third side by just solving for theta in this formula too. So this is the law of cosines and when it should be used. So maybe one other thing I will mention is that now what if you wanted to go a step further? So here we have two sides and a given angle, and we found the side that's opposite this angle, the side length that's opposite the angle. What if we're not asked for that? What if we're asked for this angle here? Let's call it phi. Well, to actually find phi then, we first apply the law of cosines to find the length of the third side. But then once we know the length of the third side, we can apply the law of sines. If you recall, then the law of sines says that A divided by the sine of phi, so the ratio of one side to its opposite angle is going to be equal to the ratio of this opposite side to its opposite angle. And so that means that we can actually solve for phi in terms of a, c, and theta, which we know. And of course, I'll talk about how to solve trig expressions later, but now it suffices to say that if you can get sine of phi on one side, so in this case, getting sine of phi on one side, we cross multiply and then we divide, and so first cross multiplying, we get a sine theta equals c sine phi, and then this means that sine of phi is going to be a sine of theta divided by c. And now this means that we can actually solve for phi because normally you can either use a calculator to find out what it is, and also there's lookup tables too. That before people had calculators, they used a lookup table to see what angle do you take the sine of to get this value, and so on. So, so this is how to use the law of cosines together with the law of sines to find all missing sides and all missing angles in a triangle.